So today we are going to learn about coding, that how the code is written. So we'll be seeing at that thing. If you haven't watched the previous videos, please go in the description, the link in the description of the playlist. Please follow the playlist from 1, 2, 3, 4, 5, 6 till 10, because it will be necessary to understand these things by the scratch. So you'll have a deeper understanding that what is going on in this lecture. So this is going to the 11th part of this series, Generative Deep Learning. We are learning about the variational autoencoders. What is the use of variational autoencoders? It is just to generate images or text or videos from the sample data. So mainly this is the thing. And after that, we'll be actually learning about the GANs, uh, generative adversarial networks. So we'll be seeing all these things. First thing is that try to Google the things if you are not understanding anything, and if you have any issue, then please write in the comments. And like what you have understand, and there is any difficulty in understanding, please comment below, and I'll be explaining in more detail if you have any issues. So I hope that now we are fine. So let's go on the uh, main subject. So we were actually seeing the training of the variational autoencoder. So we have learned about the KL divergence in the last video. So link in the description. Go and watch that if you haven't watched. And if you have watched, then if you have any issue, then please comment below. And now, how to build an overall VAE model, variational autoencoder model, as a subclass of abstract Keras model class. Okay, so actually this is the code. So this allows us to include the calculation of KL divergence term of the loss function in the custom train step method. So actually this is going to give a freedom that we can just add up the KL divergence term. So this is actually the code. You can see the code is quite longer. Uh, so actually we'll be seeing this all the things that one by one, that how it is used. So this whole video is just about this understanding this code, because it is quite important to understand. So actually I have used ChatGPT for this thing, so that each and everything we will be understanding, that why it is written, why it is not written, something like that. Okay, so that you will have a concrete understanding of the things, that how it is going on. And then we will be also understanding the gradient tape. And then in the next video we will be doing the analysis of the variational autoencoder. Okay, so let's see. So actually you can do it also, because you can just put the code in the chat gpt, and you can just say it to, okay, please give me the explanation of the code in a easier way. So you can see here the class, we have defined a class. So we have defining a class of the variational autoencoders, and it is type of neural network used for unsupervised learning, models dot model. Then then there is a def means we are defining a function actually. So this is a constructor method in it for the variation auto encoder class. Like we have made the class VAE. So it is a constructor method, and it initializes a new instance of the VAE class with encoder and a decoder, which has also neural networks. So we are doing it encoder decoder, and the kworks, KW args, is a way to accept any additional argument and store them. Okay, I hope you got some understanding that what is going on. Then there is a super, VAE self and dot init kworks. Like line calls the constructor of the parent class. It is actually calling the constructor and initializing any necessary properties. Okay, then we have this thing as an input, because these lines store the encoder and decoder networks passed to the variational class. So actually, it is passed through the variational encoder class, VAE class, and then it is getting stored in encoder decoder. Here it is stored. Okay, then there is three trackers of the total loss. The total loss is there, you can see reconstruction loss is there, then KL loss is there. So I hope that you gain some understanding that there was a reconstruction loss that how model is actually reconstructing the thing, and what is the loss between the actual and predicted one. And then the KL loss is a extra loss between the gradients. I hope you got it. Then there is actually a property is defined named matrix, which returns a list of matrix to track during the training. Okay, so we have actually defined a property called matrix. So the matrix property actually it will return a list containing the total loss tracker, reconstruction loss, scale loss tracker. It is returning all three. Okay, and then it is the method now calling the VAE instance. It is actually calling it self inputs, and which takes input and passes through the encoder and decoder networks. So for self, yeah, I think it is calling actually the VAE instance, and then it is passing the input and passing it to the encoder and decoder networks. Then there is a Z mean, Z log variance, and Z is equal to encoder input. It means that we are giving, actually, we are providing an input. We are using the encoder network to compute the mean. Okay, so we are actually computing the mean, the log variance of the latent space representation Z for the input data. Okay, then there is the line passes the latent space representation Z through the decoder network to reconstruct the input data. So this is actually doing some reconstruction. It passes the latent space representation Z through the decoder network to reconstruct. So actually we are passing that Z. We got the Z from here. So actually we will be passing it through the decoder that will do the reconstruction part. And this is the return Z mean, Z log variance reconstruction. And it will actually return the mean, log variance, and reconstruction that we have find in here. Now, this is the method. Actually, this is a function, you can say, a method, a single training step for the VAE model, taking in a batch of data. So actually, it is doing training step self dot data, comma data, and this line states the recording operations of automatic differentiation, which calculates the gradient. So we are using here TF dot gradient tape as tape. Okay, so we will be see. Okay, so let's see that what is the gradient tape. So here actually gradient tape help us to keep track of how changes in our model affect the loss. So like how it is happening, how the changes in a model is affecting the loss function. So it is basically about the gradient tape that tracks the parameter and the loss function. So that's why we have defined it, and then it is recording the operations for the automatic differentiation. Okay. Now we have this. We are passing the input data through the VAE model to compute the mean, log variance, and reconstruction. So actually we are passing the data. We are here passing the data so that it will calculate the Z mean, Z log variance, and reconstruction thing. Then this line actually computes the reconstruction loss using binary cross entropy. So we are actually using the binary cross entropy, which actually measures the difference between input data and reconstructed data. So we have actually made like reconstruction loss. We have defined the reconstruction loss and what it is. Then we have the KL loss. We have defined the KL loss, the Kullback-Leibler divergence loss, which measures how much the distribution of the latent variables, Z mean, Z log variable, differs from the standard normal distribution. You can see here that it is actually doing some actually it is reduce some. It is doing some calculation to find out the actual KL loss. Then there is a total loss. Total loss means reconstruction loss and KL loss. So it is important to do it total loss. And after that, the code computes the gradients of the total loss with respect to the trainable weights of the VAE. So it is computing the gradient of the total loss with respect to the trainable weights. Now we are using actually, we are applying the gradients to update the model weights using the optimizer Adam. So actually, we are using the Adam optimizer, and after that, there is self tracker is there, so it is actually updating, and you can see. These values update trackers. It is actually updating the tracker. You can see that it is updating the tracker with the current values of the total loss, reconstruction loss, and KL divergence loss. After that, it is returning. This code is actually returning a dictionary containing the name and result of the tracked matrix. And after that, all these things, this line actually creates an instance of the VAE class with provided encoder and decoder networks. Then we will be compiling using the Adam optimizer. What is the Adam optimizer? You can just search it. Okay, you can just search it here. That what is the Adam optimizer, and you'll be getting the thing. Here, Adam optimization is actually the stochastic gradient descent method that is based on the adaptive estimation of the first order and second order moments. So you can see it here. Full documentation is here. So you can just learn it, or you can just ask to the chat GPT in very easy way. Then actually we will just ask after this. So this initiate the actually this will actually fitting the data. This is actually fitting the train data. Epoch is 5 and batch size is 100. Okay, so let's see what is the Adam optimizer. Let's see. So it is okay. It is the optimizer. It actually what it does that it finds the fastest route to get the minimum loss. That is the point, or to get the maximum efficiency. And I stand for the adaptive movement estimation. And it is super smart guide that not only tells you where to go but also adjusts the size of the steps means learning rate on how steep the terrain is and how far you are from the tracer, something like that. So it is quite adaptive momentum. It keeps the track of the past gradients. That is called the adam optimizer, adaptive movement estimation. So it actually works on this basis. You can also have the idea by reading all these things. And the conclusion is that it is a smart guide which helps us to efficiently navigate through the vast landscape of the optimization problem. Like it can actually does the calculation of loss function in a very easy way, and it is quite good. So it is most widely used optimization algorithm in the deep learning. So I hope you got the idea that what is going on here. So you have also learned about the gradient tape. It means that it actually keep the track of the changes of the model that affect the loss function. Okay. Then we'll be seeing the analysis of the variational autoencoder. After that, we'll be actually exploring and doing the coding of the celeb A dataset, and this will be the our last somewhat last session of this. Like after this session, there will be a last one session in which we'll be doing the coding part, and after that we'll be just moving on the GAN, generative adversarial networks. So it is recommended to have this book so that you can read it, you can study it, and you can do the coding by yourself. Although I will give the everything that is important in the description. So not to worry. If you like this video, if you have any issue, just comment below. Okay, I hope I was able to make you understand the things in a very easy way. So thank you so much. Meet you in the next video.